Hello my friends, good night. Welcome to the Narcos Networking channel. My name is Luis Narciso and I am a network and security engineer. Today is the last day of the 100 regarding the BGP series. I did a commitment with myself and here I am accomplishing it. For today, we will approach traffic engineering with AS-Path Prepending, one of the attributes of the BGP. So let's start and let's take a close look at the FortiGate cluster. We are going to see the BGP process and identify the neighbors. And for that, we are going to use get router info BGP summary. And here we can see that we have two neighbors. One that is the MikroTik. This one is the Xtrm, and this one is the MikroTik. Now, let's see what are the routes that we are receiving from the MikroTik. Get router info, routing table, no, BGP neighbors, the MikroTik neighbor 124.42.24, and we are going to say received routes. And here we have the routes that we are receiving from the MikroTik. Take a close attention to this I. This I stands for internal BGP. Now, let's take a look at the routes received from the Xtrm. Sorry. That is our Xtrm. Okay, and here we can see we are receiving all these routes, and we don't see here any I. So it means that is an external BGP process. Now let's see what are we advertising. Let's see the routes advertised from the FortiGate to the Xtrm. What are we advertising to the Xtrm? So for that we are going to say get router info BGP neighbors. Our neighbor is the 114.41.14, and we are going to use the advertised routes. Okay, and we are advertising all these routes to our Xtrm. Now, what are we going to do? We are going to our Xtrm. Here it is. We are going to enter it. And now, what are we going to do? We are going to see we are going to verify the routes that we are receiving from the FortiGate. As you could see, the FortiGate is sending all these routes. But now let's see what we are receiving. Show BGP neighbor 114.41 and 41. And let's say received routes and all the routes. And look at the difference. Here we are only receiving one route to 4.4.4.4, and it has a local preference of 200. we are only receiving this route. So at this point in time, due to the traffic engineering that we have made in a previous video, so that we could culminate with an asymmetric routing problem, we had to set up the local preference for the traffic from the Xtrm to the loopback address of the FortiGate 4.4.4.4 to be 200, so that the traffic could reach the FortiGate from the nearest hop, this one, instead of the path that it was doing, that it was going from the Xtrm to the MikroTik and then to the FortiGate, as you can remember. So what can we do now? We can validate the next op to the 4.4.4.4, executing a trace route to 4.4.4.4, and we can see that we reach it immediately. So we are going to revert these configurations. We are going to say that the local preference will be 50, making the route to 4.4.4.4 from the Xtrm switch via the MikroTik preferred. And for that, we are going to edit the policy that we have set in the past. So edit policy, our name of the policy. And as you can see, we have here that we are allowing this network, the 4.4.4.4, and we are setting the local preference to 200. Now, let's manipulate this. Let's say that it's 50. Let's save it. And let's refresh the policy. Refresh policy, policy name. Okay, done. The policy is refreshed. So let's see again the routes received from the FortiGates. Show BGP neighbor, and the neighbor is 114.41.41. Received routes all. And once again, we see that we are only receiving the 4.4.4.4, but this time we can see that we have the local preference changed to 50, and notice that the route is not installed in the fib. Okay, here it was installed and it was the best path. Preferred, this from the star, and the greater sign says that it is active. So now if we do a trace route, we will go via the MikroTik. The first hop was 121.12.21, 121.12.21, and the next hop was the loopback address of the FortiGate. So now we have the behavior that we want in order to manipulate the AS-Path Prepending. So in this topology, it makes sense to send the traffic to the Xtrm, from the Xtrm to the MikroTik, and then it flows towards the Palo Alto or towards the Juniper, because if it goes towards the FortiGate, it's one more hop in the path, causing latency. As you can see, if we want to go to the Juniper or to the Palo Alto, if we have the traffic going from here to here to here, then to go back, it causes delays. But let's imagine for a while that we want to do some traffic engineering, and we need to send the traffic via the FortiGate, because a maintenance window, for example, from one ISP or XP um, on this link. Imagine that this link is going down to maintenance because they need to upgrade the SFPs, or they need to enhance something here in between to fix or to address this issue. We can use the AS-Path Prepending and say to the Xtrm peer that the way to the Palo Alto or to the Juniper is less preferred via the MikroTik than the FortiGate. And for that, we need to go to our MikroTik and say on the BGP process towards the Xtrm that the path via MikroTik will have the IS of the MikroTik prepended 2 more times, for example. And with that, the Xtrm will choose the path with less ISs in the IS path. So let's create a filter rule to prepend the IS 65000 twice on the MikroTik towards the Xtrm. Let's go to our Xtrm, to our MikroTik, sorry. Okay, now we are here. We are going to routing BGP connection, and we are going to set our router Xtrm peer 1. Sorry, it's not this. We are going to make a filter, routing filter rule, and let's set the rule for the chain. We are going to call it as Prepend AS-Path, and we are going to make a rule. And for this rule, we are going to say what? If the protocol is BGP, we are going to set the BGP path prepend twice, and we are going to accept it. Let's check if the rule is present. Okay, now we have a rule. Now we need to add the filter, the rule to the filter chain in the output of the BGP process for the Xtrm peer. So let's do it. Routing BGP connection. Let's set the Xtrm peer with the output filter chain, and the chain is prepend AS-Path. Let's see. Okay. We have here our peer, and we have the output chain to prepend the AS-Path twice. Okay, it's done. Now let's check the routes again on the FortiGate. So show BGP neighbor. It's not on the FortiGate, I'm sorry. It's on the Xtrm. It's the 100 day. I'm a little bit lost, sorry. So Xtrm, and it's late night. I'm tired. I'm sorry. But nevertheless, let's continue. Show BGP neighbor, And let's see on our 114, 41, the received routes all. And as you can see, the 114, 41 is the FortiGate. And what are we receiving? We are receiving the 4.4.4.4, and now let's check the routes received from the MikroTik. It is with the interrogation mark. It shouldn't, but let's see. Okay, what are we seeing here now? We are seeing here that we have the prepending in action. Okay, we can see now that we prepended the AS-Path twice, and here it is twice. Now, why why do we have these routes with the AS-Path prepended twice being chosen? Why is it enabled? Because we love orange, as orange means pure refreshment. I don't know if you have heard about this mnemonic or not, uh, but it's because of this that the IS-path prepend is not working. This means that the BGP attributes have priorities over each others, and the IS path is only considered after the local preference. This way, as it is, the route preferred to the 4.4.4.4 will always be via the MikroTik because it has a higher preference, 100 instead of that is superior to the local preference of the FortiGate that is 50 at this point in time. As you can see, this is for the MikroTik, and um, for the FortiGate it is 50. So um, to explain a little bit about the wheel of orange, as orange means pure refreshment. W stands for wait, is the highest, the better. It's Cisco proprietary attribute. Love. Love stands for local preference. Highest the preference, the better it is. Orange, the first orange, means originate. It's the local, the routes that are advertised through the network command or redistributed via an interior gateway protocol. As means IS path. The shortest, the better. Uh, as you can see here, we have two IS paths, and here if you only have one path here no here if you only have one path it will be chosen because it is the lower the better. Orange, the second orange means origin code. What does this mean? The interior gateway protocol is preferred over the exterior gateway protocol that is preferred over an incomplete, sorry. Uh, means. Means stands for multi-exit discriminator. The lowest, the better. Pure. Pure is for pets. The external is preferred over the internal. And refreshment stands for the router ID. The lowest router ID, the lowest IP, v4, the better. So, as you can see, being the local preference superior, it will always going to be the first attribute to be considered because the IS path is considered after. So let's change this. Let's configure a policy that says that the local preference for the routes received from the MikroTik will be 40, making the routes less preferred than the routes received from the FortiGate. So for that, we are going to copy our policy that says 200, and we are going to configure other. Let's say, for example, 40. Do we want to copy? Yes, we want to copy. And as you can see, we have here two policies. Now we need to manipulate this policy. And to manipulate this policy, we are going to edit it. Sorry, edit policy, and now we put this. Now, what are we going to say? We are going to say that we want all the routes received from the MikroTik. This is V. I need to press Shift I to edit. Let's put all the routes. Then the local preference will be 40. Escape, 2 points, right quit. And now we need to map the policy to the MikroTik neighbor. And to do it, we need to manipulate the BGP process. Show configuration BGP as similar to this one. But here our peer will be the MikroTik, and the MikroTik peer is 121.12.21, if I'm not mistaken. And now we need to refresh our policy so that it can be put in use. Refresh policy, set local preference 40. Okay, done. Now let's take a look again at the routes. Show BGP routes all. Okay, now what can we see here? We can see that we have here a greater sign. And what does that mean? That this route to 4.4.4.4 is installed on the FIB. It was provided by the peer 114.41.41, that is the FortiGate. It has the next stop as the FortiGate. It has the local preference 50, and the autonomous system has only one path, and it was the 65,000. For the other route that is not on the FIB, it was provided from the MikroTik 121.12.21. It has the next stop, that is the MikroTik. The local preference is 40, and has two IS paths. And with this, we have prepended, and we have achieved success. We can now reach the 4.4.4.4 via our FortiGate. So notice yet that we don't have the routes to 3.3.3.4, 3.3.3.5, and 5.5.5.6 and 5.5.5.7 that are the loopbacks from the Juniper device and the loopbacks from the Palo Alto. So let's manipulate the route policy of the FortiGate to accept the routes. Edit policy, set local preference 200, and we are going to press Shift I, and we are going to insert here. Notice that this must be well indented. If it's not, it can give us an error. Okay, and we are going to set the network layer reachability information as there are 2 or 3 loopbacks. I will summarize these. For example, for the Juniper 3.3.3.0/29 that provides 8 IPs, 6 used, 6 that can be used, 2 for one for broadcast and other for the network. For yes, broadcasting network. And for the Palo Alto, I will do the same because the IPs are on this range and will be received because it goes from the .0 to the .8. Okay, I need to delete the spaces. This is okay, local preference okay. Let's save it. Escape, 2 points, right quit. And now we need to do the same. We need to refresh this policy so that it can be in use. Okay, done. Now uh, let's see the routes received from the MikroTik if they are correct. Show BGP neighbor 121.12.21 received routes all. And what do we have here? We have the same. And notice that now the routes received from the MikroTik are with the AS-Path saying that to reach 3.3.3.3 and 5.5.5.5 they need to follow 3 ways. The 65,000 twice and the 65,000 is 55,003 once, 3 paths. Um, and let's see for the routes on the FortiGate if they have changed already. FortiGate it's 114, 41, 41. And boom, my friends, here we have all the routes that we need. We have the routes and they are installed, but we are going to see this in a moment. What is the command? Show BGP routes. Oh, okay. And now we have the 3.3.3.4, the 3.3.3.5 via the FortiGate and the 5.5.5.6 and 5.5.5.7 also via the FortiGate. And what can we do now? We can do a trace route to them and see what are the hopes that they are following. Trace route 3.3.3.4 and with ICMP. And as you can see, we are leaving the Xtrm via the FortiGate, and from the FortiGate we are going to the MikroTik, and from the MikroTik we are going to Palo Alto. Let's see, for example, for the 5.5.5.7. And as you can see, we are also leaving towards the FortiGate, then we are leaving towards the MikroTik, this IP here, and then we are reaching the 5.5.5.7. And my friends, with this validation, we put an end to our 100 days of the BGP series that I said I wanted to accomplish. I hope you have enjoyed this series. But don't forget to keep in touch via LinkedIn or via the YouTube channel. I will try to keep up and I will try to keep to stay providing content to you all. Feel free to reach out to me. I will be glad to talk with you via the LinkedIn. Suggest some content for me to provide. In that way, I will enhance my skills and I will help you. Because if I had the time. I will try to do it for sure because we are lifelong learners. We are always trying to improve ourselves in this world that is always changing, and it's even more now with the artificial intelligence. So let's keep us updated. Thank you for following along, and wish you all the best. See you soon.